All right, guys, last lesson of this chapter, okay? So let's begin here. It says factoring cubic and quartic polynomials. So cubic refers to the exponent being 3 to the third power, and then quartic refers to the fourth power. Okay, so we're going to be factoring these types of polynomials. So let us begin. Number 1 here, notice here, this is not written in standard form. So what you want to do first is rewrite this in standard form. So notice there's a negative x to the third power there, minus 2x squared, and then finally plus 3x. Make sure that all the signs are correct, okay? So notice here we have a negative x cubed, negative 2x squared, and then a positive 3x. Whenever your leading term has a negative, we're always going to factor out the negative, okay? Now, look here. We have a trinomial, and we want to check to see if there's anything in common all the way across. Notice here, the only thing they have in common is an x. And so I'm going to factor out a negative x, because remember, if it leads with a negative, I need to factor out the negative along with it. So notice here, I'm going to be left with a trinomial here. I'm going to be left with an x squared plus 2x minus 3. Now let's double check our work. Let's make sure that we distribute it correctly. Okay, negative x times x squared. Does that give us negative x cubed? Yes, it does. Negative x times positive 2x is going to give me the negative 2x squared. And the negative x times negative 3 is going to be the positive 3x. Okay, so now we're going to go ahead and factor this here. Okay, notice here how we don't have a number in the front of the x squared here. So what we're going to do is we're going to go ahead and just factor out to see what makes a negative 3, but at the same time a 2. So negative 3 would be just 1 times 3, right? Of course, one of these would have to be negative. And so I'm going to go ahead and see which one of these two it is. So let's go ahead and do this. Let's go ahead and split up the x. That's going to be x times x. And then I know here it's going to be 1 times 3. So I'll just put the 1 and the 3 here, because I know I'm going to have to end up with a 2 here. So if I need a negative 3, I just need to make one of these negative. But if I want a positive 2, I need to make sure that my bigger number is positive. So I'm going to put the plus 3 here and then the minus 1 there. Notice here, if I put this positive and this negative, 3 times negative 1 is still negative 3. But 3 minus 1 is going to be a positive 2. Okay, so then you just bring down the x, and that's your answer. Let's try the next one. So here notice we have a 3x cubed minus 36x squared plus 60x. It's already written in standard form. So what I need to do here is I notice I have an x in common. And so I can factor out an x. But notice 3, 36, and 60 are all divisible by 3. So I can also factor out a 3. Okay? And it looks like that's the only thing I can factor out of all these. So that's going to be 3x on the outside. Okay? What are we left with on the inside? Well, basically, you're just taking each of these and dividing them by 3x. If I divide 3x cubed by 3x, I end up with just x squared. Double check your work. Distribute. 3x times x squared. Is that 3x cubed? Yes, it is. What about 3 times what is negative 36? Well, that's negative 12. Now notice I have x over here and then I have x squared up here. So that means I need to multiply that by an x also. So 3x times negative 12x would give me a negative 36x squared. And then finally, 3 times what is 60? Well, 20. If you're not sure, use a calculator. You just do 60 divided by 3, and you get 20 there. Notice here, 3x times 20, will that give me 60x? Yes, it would. Okay, so that's what that factors out to. Okay, now let's factor this trinomial. Now, there's no guarantee that this will always factor out beyond this step. So we just have to check it. Okay, so remember the 3x goes here. Let's split the x squared into x times x. And then let's go ahead and factor out the 20. Now remember, I need a negative 12 here. So 4 times 5 is 20. But does that give me a negative 12 if I add these or subtract these? No, it doesn't. What about 6? Oops, 6 doesn't work. What about 10 times 2? 10 times 2 is 20. Oh, and look at that. If I add them, I get a 12. So I need to make sure that I end up with a negative 12. So if I make both of these negative, I'll end up with a negative 12 if I add them, and also a positive 20 when I multiply. So those are my two numbers. And that's my answer. One more of these before we get into the quartic. So, again, we look and see what they all have in common first before factoring. And notice here, they all have a 2 in common and an x. So I'm going to be left with something inside this parentheses. Okay? Now there was already a 2 here, so I don't need another number here other than 1. But 2x times what is 2x cubed? Well, x squared. Notice if I multiply 2x times x squared, I get 2x cubed. Okay? What about over here? I need a negative 2, so I need to make sure that's a negative there. Okay? And I already have the 2x. I just need 2x squared, so I just need to multiply this by another x. Notice here, 2x times negative x is going to give me the negative 2x squared. Finally, here I need another negative. Now, what's 112 divided by 2? 112 divided by 2 is 56. So this is going to be 56 there. Now, do I need to put the x there? No, because 2x times 56 will take care of the x. Okay, and so that will leave me with that. Let's try to factor out this trinomial here. So I'm going to split up the x. That's x times x. And then 56. Well, I need a 1 here, a negative 1. Let's find the factors of 56. Well, right away, I think 8 times 7. If I subtract these two, I do get 1. But I need a negative 1. So let's make the 8 negative. And that takes care of that. So we'll do minus 8. And then plus 7 right here. And that's it. That's my answer. Now let's get into quartic. Notice here, they have nothing in common. I have x to the 4th plus 3x squared minus 4. I have nothing in common. Okay? But it's still considered a perfect square. Even though it's a quartic, whenever it's an even exponent, we can go ahead and factor out using the same methods we were factoring these right here. Notice here, we have x squared minus x minus 56. We were able to factor it. Well, as long as this exponent here on the second term, on the middle term, is half of the first term, and they're both, well, and the first one is even, okay, then we can try factoring using this method here. So notice here, the exponent here is even. That means it's a perfect square. And then this middle term's exponent is half of that. So we can factor it like this. Okay? So let's go ahead and split this up into x squared times x squared. That'll give me the x to the 4th power. Now, I need to find the factors of 4. Well, there's only one pair of factors. It's just 1 times 4. Can I get 3 out of that? Sure. I can get it by subtracting. 4 minus 1 is 3. Now, I need a positive 3, so I need to make sure that the 1 is negative. So all I have to do here is put minus 1 and plus 4. Notice how that takes care of the negative 4. Negative 1 times 4 is negative 4. Let's just double check before we continue because we're not actually done yet. Notice here, if I were to multiply these two here and these two here, I get 4x squared minus 1x squared, which is just x squared. Doesn't that give me 3x squared in the middle? Yes, it does. So you see, it all works out. We already did the x squared times x squared, that's x to the 4th, and then negative 1 times 4 is the negative 4. Okay? But let me erase this here. I want you guys to notice here this parentheses here. X squared minus 1. That should be familiar to you. That's a difference of squares. So that means I'm going to get 2 more factors out of that. That's just going to be x times x. And then to get negative 1 is going to be positive 1 times negative 1. Bring down the x squared plus 4. Notice this is not a difference of squares because it's not a difference. It's addition. And we don't have a special pattern for addition. So we're done. Next one. Let's do it the same way. Okay, notice here, we look at the exponent here, it's even, and then this one's half of that, so we can factor it using that method. Well, we can try and see if it works. The numbers have to work still. So we're going to split this up. That's going to be x squared times x squared. And then I need a negative 32. I'll just write 32 right now. And then let's just go ahead and use numbers. First thing that comes to mind is 8 times 4. Notice here, if I subtract these, 8 minus 4, I get 4. So these are going to be my numbers. And I need a negative 32, so I need to make sure that the smaller number is negative. So that when I subtract them, I get a positive 4. So, plus 8 minus 4. Notice, 8 times negative 4 is going to be your negative 32. Look what we have here. Another difference of squares. So go ahead and factor this. This is going to be x times x. And then to get negative 4, negative 2 times positive 2. And then we get x squared plus 8. Okay, that's my answer for that one. A couple more, then we're done. Look at this here. The exponent's way higher than 4 here. Well, not way higher, but it's the exponent is 5. Okay? So, first of all, I'm going to go ahead and rewrite this in standard form with the highest exponent first. So, negative x to the 5th plus 13x cubed, and then minus 36x. Now, notice here, this is not an even exponent. It's odd. Okay, so we can't factor it like the other examples we just finished. But notice here, they all have an x. So that means I can factor out an x. And since it starts with a negative, I'm going to factor out a negative 1x. Okay? So what does that leave me with? Well, I'm going to be left with, if I divide 1x out of this one, I'm left with 4 of them. Okay? So that leaves me with x to the 4th, which is what we were doing in the last example. Now, a negative times a what is going to give me a positive? Well, a negative times a negative. So this has to be negative here. I'm going to have 13x. Now remember, if I multiply these two, negative x times negative 13x, that'll give me positive 13x squared, but I need x cubed. So I'm going to just put here to the second power. That way, when I multiply this negative x with this negative 13x squared, the x squared times x is going to give me the x to the cube. Okay? Now notice here the last one is negative 36x, but I already have a negative here. So I need to multiply this by a positive, and then we have 36. Let's double check, distribute here just to make sure that we get exactly what we have right above. So negative x times x to the 4th is negative x to the 5th. And then we have a negative times a negative is going to be a positive, 13x cubed. And then finally, a negative times a positive is going to be a negative 36x. Okay? So now we can go ahead and try to factor this like we were doing with the last one. We're going to do x squared times x squared and then 36. Right? 9 times 4, that's what comes to my mind first. 9 times 4. Notice here, if I add both of these, I get 13. So these are my two numbers. I'll just put minus 9 and minus 4. Bring this here down. Now, what's this? We have two differences of squares. So notice here, I'm going to have two parentheses that come out of this one, two more factors, and then two more factors that come out of the other one here. And then, of course, a negative x at the bottom. So this is going to be x times x, and then negative 9 is going to be negative 3 times positive 3. For the next one, it's going to be x times x, and then we're going to have negative 2 times positive 2. And that's it. Two more to go. Same type of problem. Let's go ahead and write it in standard form. So we have x to the 5th. Now which one comes next? Oh, the negative 3x cubed comes next. And then we have negative 10x or minus 10x. Okay? So right away I see they all have an x. So I can factor out an x. So what am I left with? X to the 4th minus 3x squared minus 10. Okay? Factor this here. And so that's going to be x squared times x squared. And now I need a 10, so a negative 10, right? So 5 times 2, I notice that's 10. And if I subtract, I get 3. But I need a negative 3, so let's make the 5 negative. Okay? And of course, we wanted the 10 to be negative also, so that's why that's one of them is negative. Okay? So let's go ahead and put minus 5 and plus 2. Any difference of squares here? Nope. So we are done. Last one. Let's go ahead and write this in standard form. So this will be negative x to the 4th plus 10x squared minus 9. Now notice this one's already written in quartic form, right? We have it to the 4th power, and that's half. But notice we have a negative at the beginning. So what I need to do here is factor out a -1. There's no variable. They don't all have a variable in common. So the only thing I need to factor out is a -1 at the beginning. Okay? That's going to leave me with x to the 4th minus 10x squared plus 9. Notice all that happened was the signs changed because I factor out a -1. Distribute. Double check it. -1 times x to the 4th is -x to the 4th. -1 times -10 is +10. -1 times +9, -9. Okay? So let's go ahead and factor this like the other ones. Let's go ahead and put x squared times x squared. And then 9. What comes to mind is 3 times 3. But notice that's not going to give me a -10 or a 10. What about 9 times 1? There you go. 9 plus 1 is 10. But I need a -10. So make them both negative. And notice that's going to give me a +9 when I multiply them. What about these two here? Difference of squares again. So that's going to be 2 more parentheses from there and then 2 more from the second one there. So it's going to be x times x, -3 times +3, x times x, -1 times +1 there. And that's your answer. And that's it.